Hi everyone, we're the team South America of the class Control and Stability of an Aircraft from the University Autónoma of Baja California. And in this practice, we're going to talk about stability and show how it works in our model aircraft. Before seeing how the practice works, we have to know what is stability. Stability is an inherent quality of an aircraft to correct for conditions that may disturb its equilibrium and to return or to continue on the original flight path. To make possible this practice, we have to have the software tracker or model aircraft that we use in last practice, a platform to sustain the aircraft, and use the wind tunnel. For the practice, we have to film about 3 minutes of how the movements of the aircraft inside the wind tunnel with a specific velocity were. And as we can see, at the beginning the aircraft model was upside down, and then when we turned out, the wind tunnel was the aircraft in a specific angle of attack that were changing since the wind was working as a disturbance for the aircraft. But the aircraft kept trying to return to the original angle of attack to have a specific lift force. The next part of the practice it is to import the video that we filmed in the software tracker. This is going to help us to analyze the angle of attack that the aircraft had to understand what happened with the movements of the aircraft and what type of stability we had. Here in the tracker, we apply some conditions, like the distance. Here we use the length of the aircraft, and the coordinate axes are the purple lines, and we see some red dots. Those are applying the white point that we made in the aircraft. For the past process of the practice, we export the data that the software tracker made to the software itself. This is to make a rough graphic that is shown in the video, and if we can see, it shows every angle of attack that the aircraft have in the video, but the middle part that looks like a straight line, it is our major part of study. So we made this graphic that shows better how the angle of attack was moving and changing in the video. So the graphic makes us understand that the type of stability we have. And as we can see, was oscillating the angle of attack between the 76 degrees to 85 degrees approximately. To understand more about oscillations, we have to know about dynamic stability, that it is concerned about with the time and history of the motion of the aircraft after its disturbance for its equilibrium point. We have 3 types of oscillations in the dynamic stability. The one we're seeing in the graphic, it is called on-damped oscillation. In conclusion, in our aircraft model, it is seen in the last graphic that the region disturbance with the time it is not seen. So that means it is not fully aerodynamic and doesn't have the best dynamic stability. But that doesn't mean it is the worst. If no, it is just another type of aircraft. So for that, to make it more stable, we can add ailerons, elevator, rudder, etc. So that was just the end of the practice 2. It is about stability, how the dynamic stability works, and to make better understand the theory that we're seeing in class. And that's the end.